Okay, let's see if we can get this in the recording because my hand's in the way. Okay, pressing play. Yeah, that's what happens when the magnets fly off. Just out of here first. Easy to knock the ones off the rotor. Well, I'm down to my last two needles. So if I find any more flying off like that, I'm either going to have to tear the shop apart and find out where they went or go buy some new ones. Well, I spun it up too fast. Needles came off, struck our rotor, and consequently needs some repairs. So I figured, why don't I go ahead and effect the repairs. Check off the old hot glue here. Trash. Fortunately, I marked these north and south. I only had to do this about 4 or 5 times, so it's not that big a deal, actually. Notice the difference in the sizes? Oh, wait a minute. I think this one weighs more. Put them on there so I can get a different marker pulse on the scope. So I'm looking for souths right here. I don't know if you guys can see that in the south. So we got south marked on there. Show you how easy it is to do this around the screen. Just get some hot glue in there. Grab your fingers a little bit. I just use this black line as one marker. And I just line it up with the guy across the street there. Get him close, just eyeball it, believe it or not. Right down the middle. Just that simple. Makes it easy. Whoever invented hot glue should be a millionaire by now. There's probably some poor guy working for a major corporation like 3M. Alrighty. See if we can get this one somewhere near close. That's all they have to be, actually. It's close. The rotor is floating on. Balance itself out a bit. Stator as well. And we're back to balanced. In case you guys want to know, what we got there, it's just a, I can get that in the shot, it's an Everflow. Came off from the thermocouple volcano heat sink. And this one's an Avid. Kind of covered it up. Avid cleaners. Wires came off this one the other day. Don't need the wires. I'm powering that guy. Powering the other guy. So, I put this on a little bit of an incline. Probably about 30 degrees, something like that. But take some of the gravitational load off of that bearing. It runs better for some reason. Just want to demonstrate by hand the alignment when the radius is correct. You see the equator line of each of these is lined up with the other. The stator equator is lining up with the rotor equator. Now, if we're really close, you'll actually see a slip. See that slip in there? Lateral tangential slip. across like that. So that would be a point, you know, if you're too close on your magnetic radius, you're going to have that tangential slip right there, and that's going to manifest itself as a rotor decrease in RPM. And then it's going to have a really high steep flip as it goes past that equator and it slips again, and that's the effect you're going to have. Now if you pull that back to where you're getting a bigger radius, you can actually find that you're going to have a relatively round relationship. Unfortunately, what we're seeing here is the magnets inside the fan causing that little stamp over effect. But the point is, with valves, rotors, the right spacing, you can get these equators, which I think Al referred to as a block wall. And, you know, in a sense, you could call it a block wall if you grouped all the domains on one half and called it one domain, all the domains on the other half is called that neutral zone or block wall. But technically, it's not, as they've indicated in the post. And you could call it an aclinic line, but it's not an aclinic line. It really only relates to the Earth. So it's a permanent magnet equator. That's the best way to refer to it, I guess. And they're in alignment. Now, if we're going in the opposite direction, what would we have? You know, we still have alignment here on the two equators, but this would be spinning in the opposite direction, like that, and then lining back up on the equator. And hopefully, if I can get this spinning counterclockwise, we can see some of that effect. I will mention that I saw on some of the stroboscopic work that I was doing, I saw a small precession on that equator line of about, you know, I don't know how many degrees that is, 2 or 3 degrees, where the rotor, which is the driving mechanism here, was preheating. You know, even though they appeared to be in phase, there was a little bit of precession, you know, about like that. You know, this would be perfectly lined up on the equator, and there's a little bit of precession there. And it seems to be relative to the speed. So I have a feeling if they were in sync, at a higher speed, we'd end up with more precision, and at a lower speed, we'd end up with perfect effect. And that's probably due to inertial lag. So, we got it repaired, down to our last 2 Neos. I've been using air from the compressor in the shop to try and get this to sync and reverse sync, and I haven't had much success. I've added these 4 screws to elevate the fan. I was getting heating problems. I wasn't getting any airflow through, and the motor would heat up, and the glue would melt, and the thing would come apart. So I added screws to allow some airflow, and then we got some space in between. You know, the CD in there, we've got a little gap for the air to come out, and that kind of keeps it cool. But since I put those screws on there, I've been having trouble getting this to sync anti-gear-wise. So, either the fan's moving faster, and it shouldn't be, or the screws are altering our magnetic field in such a way that it's prohibiting it, or some other mechanism, you know, maybe I gotta wait for the full moon. Anyways, let's see if we can get an anti-gear-wise sync here, and if we can, then we'll flip things over for scope mode, stroboscope that is, and we'll see what we get. Uh-oh, got another problem. Got a new problem, look at that. Well, I'm gonna break out the soldering iron and fix that broke wire, I guess, so we'll be back. Okay, this is taking me longer than I expected to get this synced back up, but I finally figured out what my problem was. I had an imbalance in the rotor, and every time it would try to sync, it would throw it out of balance, and that would counteract the effect. So we've got that taken care of. We're going to set this up now for you know what?